Welcome back to the deep dive. I have to be honest with you, looking at the stack of research you've pulled for today, I'm feeling a little vertigo.
Oh, I can imagine. It's a heavy one.
It is. We are walking a line that is so thin, it's practically invisible. We are sitting right on the razor's edge between the hardest of hard sciences, we're talking quantum physics, and on the other side, the deepest, most ancient spirituality.
And usually those two things are like oil and water.
Exactly. They don't mix?
It is a precarious place to sit, I'll admit. You have, rigorous mathematics and experimental data on one side, and then profound, subjective, mystical experiences on the other.
And those two worlds do not talk to each other.
No. In fact, historically, they usually yell at each other.
Right. But this stack is fascinating because it's trying to force that conversation to happen. I mean, we've got materials ranging from Stanford astrophysicists and neuroscientists to near-death survivors.
It's pretty broad spectrum.
And on the flip side, we have some very loud, very angry skeptics who call this whole topic quantum mysticism. They are basically shouting pseudoscience from the rooftops.
And you need that voice in the room. It's a collision of worldviews. And the central question we are unpacking today is essentially, what is a human being?
Yeah, what are we?
Are we just biological machines, wet computers made of meat? Or are we something else entirely? Is the brain a generator of consciousness, or is it a quantum receiver?
That is the mission today. We are unpacking the collision of quantum physics and human consciousness. And to do that, we have to start by looking at how we used to see the world. The old view.
The classical view.
Because according to our sources, specifically the lecture from the Stanford astrophysicist, most of us are walking around with a model of reality that physics abandoned almost a century ago.
That's absolutely right. We call it the Newtonian worldview, or, classical mechanics. It's the world of the billiard ball.
The billiard ball. Okay, break that down.
In this view, the universe is a giant clockwork mechanism. Everything is made of matter, solid, distinct stuff. Cause and effect are linear.
If you hit the ball, it moves.
Precisely. It's predictable, it's safe, it's comforting in a way.
And in this view, the brain is just another machine, a very complex toaster, basically.
Exactly. It's the matter-first perspective. Matter is fundamental. You have atoms, they form molecules, molecules form cells, cells form neurons.
And the logic follows from there.
Right. The prevailing theory in neuroscience for a long time has been that when you get enough neurons firing together in a complex pattern, poof, you get consciousness.
So your thoughts, your feelings, my sense of me,
Yeah.
it's all just a byproduct.
In this model, yes, it's the exhaust fumes of a biological engine. When the engine stops, the smoke clears, and you're gone.
It's a bit depressing, honestly. It's the meat robot theory.
It is. It's very mechanistic.
But the Stanford source points out that we still teach this solar system model of the atom in high school. You know the one I'm talking about, right?
Oh, absolutely. The nucleus is the sun, and the electrons are these perfect little planets orbiting around it.
It looks so tidy. It makes sense.
It is quaint, and it is completely wrong. As the source notes, that picture serves no purpose in actual physics anymore. It's a useful lie for ninth graders, but that's about it.
So what replaced it?
Quantum mechanics, which really took over about 90 years ago, suggests that the universe isn't built of hard, solid things at all. It's structured in layers.
Layers of creation.
Yes. You go from the macroscopic, the chair you're sitting in, down to the molecular, then the atomic.
Yeah.
But when you go deeper, when you look inside the atom, the stuff disappears.
What do you mean disappears?
You don't find little hardballs. You find vast emptiness, and then at the very bottom, you don't find matter at all. You find a field, a unified field of potential.
And the Stanford source called it a field of pure intelligence or pure being.
He did.
Which I have to say sounds less like physics and more like theology.
And that is where the trouble and the excitement begins. Because if the foundation of the universe isn't dead matter, but a dynamic, intelligent field, then our relationship to reality changes completely.
Okay, let's unpack this, because to understand why this shift happened, we have to talk about the experiment that broke reality.
The one and only.
The double-slit experiment. This came up in multiple sources: the hidden library, What the Bloop Do We Know, and even the skeptic Professor Dave. Now, most people have heard of this, but I want to really get into the weeds of why it's so disturbing to our sense of reality.
It is the most famous experiment in quantum physics for a reason. It defies all common sense. It just breaks the rules of how we think the world is supposed to work.
So, lay it out for us. This starts way back, right?
Yeah.
Thomas Young, 1801.
Way back, Young was trying to figure out if light was a particle or a wave. So he set up a very simple apparatus, a barrier with two tiny vertical slits in it, and he shone a light through them onto a back screen. Now imagine you're firing paintballs at a wall with two windows. If light were made of particles, like little bullets, what would you expect to see on the back wall?
Two lines of paint. A pile behind window A and a pile behind window B. That's what matter does.
Exactly, direct hits. But that's not what happened.
Not at all.
Instead of two bands, he saw an interference pattern, a series of alternating light and dark bands spread out across the back wall.
Which is what waves do.
That is what water does. If you push water through two slits, the ripples overlap. Where two crests meet, the wave gets bigger. That's a light band. Where a crest meets a trough, they cancel out. That's a dark band. It proved light was a wave.
Okay, so light is a wave. That seems fine. Water is a wave. Sound is a wave. Why is this a problem?
Because 100 years later, scientists started doing this with matter, with electrons, tiny, tiny pieces of physical stuff.
So now we're firing the paintballs.
Now we're firing the paintballs, one at a time. Logic dictates that a single electron, which is a particle, a physical object, should go through one slit or the other. It can't go through both.
Right. It's like throwing a single baseball. It goes through the left window or the right window, period.
But it didn't. Over time, even firing them one by one, they built up that same interference pattern on the back wall.
Wait, hold on. I need to stop you there. If they're firing them one at a time, what on earth are they interfering with?
That is the million-dollar question. That is the mystery. The only mathematical explanation is that the single electron leaves the gun, becomes a wave of potential, goes through both slits simultaneously,
It can't.
interferes with itself, and then hits the wall. It is in what we call superposition. It exists in all possible states at the same time. It is going through the left slit, the right slit, neither, and both, all at once.
So matter isn't solid. It's a cloud of probability until
Until they looked.
the observer.
This is the twist that keeps physicists up at night. They decided to put a detector by the slits to see which one the electron actually went through. They wanted to catch it in the act.
They wanted to solve the mystery.
But the moment they turned on the detector, the electron stopped acting like a wave. It snapped back into being a particle.
And what happened on the screen?
Two bands. Just like the paintballs, the interference pattern disappeared completely.
That is absolutely bonkers. The moment they watched it, it changed how it behaved. This is the observer effect.
Correct. It's what physicists call the collapse of the wave function. Before observation, reality exists as a cloud of infinite probabilities. Observation forces the universe to make a choice. It collapses that cloud into a single concrete event.
This is where the "what the bleep do we know" source brings in that holodeck analogy. The idea is that the brain is essentially running a simulation. We think we see reality, but we're seeing a collapsed version of it that fits our expectations.
It raises a profound philosophical implication, often called the von Neumann-Wigner interpretation. Is reality out there, independent of us? Or is reality in here, created by our interaction with it?
Does the moon exist if no one is looking at it?
That's the one. Einstein hated that question. He famously said, "I like to think the moon is there, even if I am not looking at it." But quantum mechanics forces us to ask it.
And it gets weirder. We didn't even touch on the delayed choice experiment or the quantum eraser in the intro, but looking at the deeper notes here, that suggests this effect happens across time, doesn't it?
Oh, absolutely. The quantum eraser experiment is even more mind-bending.
Well,
I mean, it suggests that if you measure the particle after it has already passed through the slits and hit the wall.
after.
Yes, after. That decision seems to reach back in time and change whether the particle behaved as a wave or a particle when it went through the slits in the first place.
That sounds like time travel. That completely breaks my brain.
It suggests that our common sense notion of time, this arrow moving from past to future, it's just not how things work at a fundamental level. The choice to observe something now can influence how it unfolded then. It breaks the arrow of time.
We're going to put a pin in that for later because that has huge implications for the whole manifestation topic. But first, there was that story in the source material about the Native Americans in Columbus. It's used to illustrate this brain filtering idea.
Yes, the account suggests that when Columbus's armada appeared on the horizon, the indigenous people couldn't see the ships, literally could not perceive them.
Why not?
Because they had no neural pattern for clipper ship. It was so far outside their known reality that their brains just filtered it out as, weird waves or background noise.
Their brains didn't have a category for it, so it was invisible.
Now, we have to be careful with historical accuracy on that specific anecdote as anthropologists debate it. But as a metaphor for cognitive neuroscience, it's powerful. The brain filters out what doesn't fit its model. We see what we expect to see.
So if the double slit experiment shows that observation collapses probability into reality, and if our brains filter what we observe based on what we already know,
Then we are trapped in a loop. We only see what we believe is possible.
which means we keep collapsing the same reality over and over again.
And that prompts the big question. If we could change our internal observation, our expectations, our beliefs, could we collapse a different reality out of the quantum field?
That is the big so what here. If we create reality by observing it, do we get to choose our timeline? But before we go too far down that rabbit hole and start trying to manifest winning lottery tickets, I had to play the other side. We have to pump the brakes and pump them hard.
It's time for the Skeptic's Corner.
Yes. We have a source, Professor Dave explains, who basically listened to everything we just said and is now screaming into a pillow. He calls this quantum mysticism. And honestly, looking at his points, he's got some heady ammunition.
It is crucial to hear this critique because there's a very real danger of taking scientific terms and using them as, loose metaphors, but pretending they are still science.
Right. So Professor Dix breaks down a few key points. First, the word energy. In the spiritual community, people say things like, oh, that place has bad energy, or I'm sending you good energy. Dave says, stop it.
From a physicist's perspective, energy is a very specific thing.
That's
The capacity to do work. It's measured in joules. It's not a vibe. It's not a mood.
It's not a feeling.
It's not. You can't just redefine a physical constant because it feels poetic. When a physicist talks about energy, they mean a very specific mathematical quantity.
Okay, fair point. Then there's the observer fallacy. This is the big one. When we say the electron changed because it was observed, we imagine a person with eyes, a conscious being, squinting at it.
The little man in the lab coat.
Right. But Dave says that's not what observation means in physics at all, is it?
He's technically correct regarding the standard interpretation. In quantum mechanics, observation usually just means interaction. Any interaction. To see an electron, you have to bounce something off it, like a photon of light.
So you're hitting it with something else.
You're hitting it. That photon collides with the electron and changes its path. It's a physical collision, not a conscious looking.
Yeah.
The electron doesn't know you're watching. It just knows it got hit by a photon. The measurement itself is what disturbs the system.
So his argument is, you can't scale this up. Just because a tiny electron behaves weirdly when you poke, it doesn't mean I can heal my body with my mind or manifest a Ferrari with my thoughts.
It's a question of scale.
But the biggest hurdle he throws at us is decoherence. And I want you to explain this because it really sounds like the deal breaker for the whole quantum mind theory.
Decoherence is the enemy of all things quantum. To maintain that fragile state of superposition, where the electron is in two places at once, you need a pristine environment. You need absolute zero temperature. You need a perfect vacuum. You need total isolation.
Because if anything bumps into it, a stray photon, a bit of heat, another atom, the superposition just collapses.
Instantly, it decoheres, it vanishes. And the brain, what is the brain? The brain is a warm, wet, noisy soup.
It's 37 degrees Celsius, it's full of water and salts and electrical noise.
From a physics standpoint, it's a chaotic hurricane. Professor Dave argues that any quantum state you could possibly form in the brain would decohere. It would vanish in femtoseconds.
So femtoseconds, how fast is that?
A quadrillionth of a second. Way, way too fast to have any impact on a neuron firing, which takes milliseconds.
So logically, the brain can't be a quantum computer, it's just too hot and messy.
That is the standard decoherence argument, and it is a very strong one. It's the reason most neuroscientists dismiss these ideas out of hand. By the time you get to the scale of a neuron, all that quantum weirdness has canceled itself out, and you're back to classical billiard ball physics.
Acknowledged. The friction is real. But, and here's where it gets really, really interesting, our stack includes sources that argue biology has solved this problem, that nature is using quantum mechanics even in that warm, wet soup.
This is where we pivot to Sir Roger Penrose and Stuart Hameroff. This is the Orchor theory.
And we should say, Penrose is a Nobel laureate, right? He's not some guy on YouTube with a crystal collection.
Sir Roger Penrose is a giant in the field.
Mm.
He worked with Stephen Hawking on black holes. He's a mathematical physicist of the absolute highest order. And Stuart Hameroff is an anesthesiologist, a very unlikely duo.
A physicist and a doctor.
But they argue that the wet and warm critique, while valid for most systems, misses where the action is happening in the brain.
How? How did they get around the decoherence problem?
They believe consciousness doesn't arise from the whole brain buzzing together at the synapse level. That's the classical view. They think it happens on a much, much smaller scale.
Mm.
inside the neurons in tiny, tiny structures called microtubules.
Microtubules. I vaguely remember these from biology class. They're like the skeleton of the cell, right? The scaffolding.
Exactly. They are microscopic tubes that give the cell its shape, and they act as like little train tracks for transporting proteins and things. But Penrose and Hamroff looked closer. These tubes are made of proteins called tubulin. And these tubulin proteins are arranged in a very specific lattice, a Fibonacci spiral, actually.
Of course it's a Fibonacci spiral. Nature loves those patterns.
It does. But here is the proposed mechanism. Inside these tubulin proteins, there are tiny hydrophobic pockets.
Hydrophobic, so they repel water.
They repel water. They're little dry spots where water can't get in. Amaroff argues that these pockets act as a biological Faraday cage.
A protected zone.
Yes, a shield from the noisy, wet environment of the cell.
Yeah.
And inside these nonpolar pockets, electrons can delocalize. They can enter superposition without immediately decohering.
So the brain basically has billions of tiny quantum computers tucked away inside the scaffolding of the neurons themselves.
That is the theory. The tubulin dimers, as they're called, can exist in two states at once, like an on and an off switch at the same time. It becomes a quantum bit or qubit. And when enough of them become entangled across the brain.
Wait, entangled, as in spooky action at a distance, connected instantly.
Yes, they vibrate in unison, in a coherent quantum state. And when that state reaches a certain threshold, Penrose calculates this using the uncertainty principle. It can't sustain itself anymore. It collapses, a self-collapse. And that moment of collapse is a moment of consciousness.
So consciousness isn't a continuous stream like a movie. It's a series of discrete quantum collapses happening over and over again.
Like frames in a film. He calculates it happens about 40 times a second. That's the ORCHA-R, part orchestrated objective reduction. The bing, bing, bing of conscious moments.
That sounds incredible, but is there any actual proof? Or is this just beautiful math?
For a long time, they were laughed at. It was considered fringe. But recently, we found solid evidence of quantum effects in other biological systems.
Like what?
Photosynthesis, for example. For the longest time, we couldn't figure out how it was so efficient. We now know plants use quantum coherence to harvest light. An exciting little packet of energy explores all possible paths to the reaction center simultaneously to find the most efficient one.
It's trying all the options at once.
So a piece of moss is a quantum computer.
Wow.
In a way, yes. And the European robin, there's a bird that navigates using what's called a quantum compass in its eye. It involves a molecule called cryptochrome, and it can actually see the Earth's magnetic field using quantum entanglement.
So if a bird has a quantum compass and a fern uses quantum harvesting, it's not really that crazy to think the human brain, the most complex object in the known universe, might be using it too.
It creates a plausible bridge. If biology uses quantum mechanics for navigation and energy, why not for information processing? It's not such a stretch anymore.
And this leads to what I found to be the most compelling piece of evidence, the anesthesia argument. Since Hameroff is an anesthesiologist, he looks at this from a very practical perspective.
It is the smoking gun for their theory. Think about it. When you go under general anesthesia, you don't just go to sleep. Your consciousness is obliterated. It's switched off.
Gone.
But your brain doesn't turn off. If you hook someone up to an EEG while they're under, the brain is still very active.
The electrical signals are still firing.
The electrical activity is there. The sensory inputs are arriving at the brain. The hardware is still running. But the user is gone. The lights are on, but no one is home.
So Hameroff's question was, what exactly is the anesthetic gas doing? What is it turning off, if not the electricity?
Exactly. And he found that dozens of different anesthetic gases with very different chemical structures all work in one specific way. They bind specifically to those hydrophobic pockets in the microtubules we just talked about.
No way.
Yes. The gas molecules fit perfectly into those little pockets, and they disrupt the quantum state. They prevent the electrons from entering superposition. They cause decoherence.
So you pull the quantum plug, and consciousness vanishes, even though the classical computer, the synapses, is still humming along just fine.
Which implies that consciousness is not the electrical humming. It implies consciousness is the quantum state inside the tubes. And if that's true, it changes everything.
How so?
It means the brain isn't generating consciousness like a factory making smoke. It's receiving it. Or at the very least, it's facilitating a connection to a quantum field that is fundamental to the universe.
So if the brain is a receiver, like a radio, smashing the radio doesn't kill the broadcast.
Now you're stepping into the metaphysical implications. But yes, that is the logical extension. If consciousness is a fundamental property of the universe, that unified field we mentioned at the start, and the microtubules are just the antenna, then death looks very different.
Okay, so we've looked at the brain, and that's heavy enough. But our sources say we're missing a huge piece of the puzzle if we ignore the rest of the body, specifically the heart.
The heart is absolutely fascinating in this context. We usually think of it as a pump, a mechanical valve, right?
Yeah.
But electrically, it is a monster.
The sleepy physicist's source dropped a stat that blew my mind. The heart generates an electromagnetic field 100 times stronger than the brain's electrical field.
100 times stronger electrically. And the magnetic component is even stronger, about 5,000 times stronger than the brain's magnetic field.
5,000? That seems impossible.
It's measurable. You can detect it up to 3 feet away from the body with standard squidded magnetometers. You are literally walking around in a bubble of magnetic energy that is being generated by your chest.
And this isn't just noise. The field is carrying information.
Right. This connects to the work of Dr. Joe Dispenza and the HeartMath Institute. They study something called coherence. The heart and the brain are in constant communication, but the quality of that signal matters enormously.
He talks about coherence versus incoherence. What does that actually look like on a monitor? What's the difference?
Think of incoherence like a bad traffic jam. On a graph of your heart rate, it looks jagged, erratic, chaotic. This is the stress state.
Fight or flight.
Exactly. When you are in survival mode, you're angry, you're frustrated, you're scared, your heart rhythm becomes disordered.
He described it as stepping on the gas and the brake at the same time.
That's a perfect analogy. You're sitting in traffic, worried about being late, angry at the guy in front of you. Your body is pumping out cortisol and adrenaline. You're mobilizing huge amounts of energy to fight a tiger, but you're just sitting still. That is incoherence.
And the brain gets pulled into that chaos.
It does. The different parts of your brain stop talking to each other effectively. You lose the big picture. You're just focused on the threat.
And coherence is the opposite.
Coherence is harmony. If you look at the heart rate variability monitor, the jagged line becomes a smooth, beautiful sine wave, like rolling hills. This happens when you consciously shift into elevated emotional states.
Like what? What kind of states?
Gratitude, compassion, appreciation, joy. When you genuinely feel those things, the heart's rhythm becomes orderly and coherent.
And because that magnetic field from the heart is so strong, it pulls the brain along with it.
It entrains the brain. Entrainment is a physics term. The stronger oscillator pulls the weaker one into rhythm with it. The heart pulls the brain out of that high-stress, high-beta brainwave state and down into alpha or even theta.
And those are the creative states, right? The suggestible states where you're more open to new information.
Yes. And this is where the physiology of the field gets really practical. Dispenza's research claims that when you achieve this state of heart-brain coherence, you aren't just feeling good. You are sending a completely different signal to every single cell in your body.
This is the pharmacy within idea.
Correct. He mentioned studies from his week-long retreats where in just 7 days of doing this meditation work, participants showed significant changes in their gene expression.
This is epigenetics, changing how your genes are read without changing the code itself.
Exactly. They upregulated genes for immune regulation, specifically the unoglobulin A, which is the body's primary defense against bacteria and viruses. And at the same time, they downregulated the genes responsible for inflammation and oxidative stress, the drivers of aging and disease.
Just by changing their emotional state. That sounds like the placebo effect on steroids.
Well, Dispenza's whole argument is that the placebo effect is this quantum biological process. What is a placebo? It's a belief, a thought, and a feeling changing your physical biology. He just wants to make it a conscious and repeatable process.
So what's the mechanism?
The mechanism he proposes is that the coherent heart field sends a new signal to the amygdala, the brain's alarm center, that essentially says the trauma is over. It tells the body it's safe. It resets the baseline. The body stops preparing for a war that isn't happening and starts using that energy to repair and regenerate itself.
That is incredible. It implies that our biology is literally listening to our energy.
And that brings us right back to the skeptic's critique of the word energy. Professor Dave says energy is just joules. But here, we are talking about measurable electromagnetic fields that are organizing biological matter. That is physics. It's biophysics.
So it's not woo, it's just a different application of physics.
The controversial part is how far you can take it. Can you cure a terminal disease just by thinking? The data on stress certainly suggests you can cause disease by thinking, so the inverse should be possible, at least in principle.
So if we can change our internal state to change our biology, The next logical step is, can we use it to change the world outside of us? This brings us to the topic of manifestation, which I'll admit usually makes me roll my eyes, but the quantum shift source flips the whole concept on its head in a way that actually connects back to the physics we started with.
This was a really unique take. I found it fascinating. Manifesting backwards.
Yeah. Usually when we think about our goals or the future, we think of it as a timeline. I am here at point A. The thing I want, the job, the relationship, the health is over there at point B, and I have to walk a path to get to it.
Linear time. The Newtonian view strikes again.
But the source says, no, that's all wrong. The future isn't ahead of you. It's a frequency that is already active right now.
If we accept the quantum view, remember the many worlds interpretation, or even just the basic idea of superposition, then every possible future exists as a potential in the field right here, right now. It's not a place you go to, it's a channel you tune into.
And this ties back to that mind-bending, delayed choice experiment we pinned earlier. If observing something now can affect the past, then time is symmetric. The future can affect the present just as much as the past does.
Exactly. In physics, most of the fundamental equations work just as well forward as they do backward in time. So the idea is that you aren't creating a future from scratch, you are selecting one that already exists. You're remembering your future.
The analogy they used was the mirror. And I love this because it's so simple but so powerful.
It clarifies the frustration people feel when they try this stuff and it doesn't work. Imagine reality is a perfect mirror. If you stand in front of that mirror and you see a frowning reflection, you can't reach out and physically turn up the corners of the mouth on the glass. It's impossible.
You have to smile first.
You have to smile first. The reflection follows your lead, not the other way around.
But most of us are trying to change the reflection. We're working hard, struggling, trying to force the world to change while we're still frowning on the inside. We're still feeling the lack.
Precisely. We are trying to manifest a new future while holding the emotional signature of the past. If you want abundance but you feel scarcity, the quantum field, or the mirror, can only reflect the scarcity back to you. Because the field doesn't respond to what you want with your thinking brain. It responds to who you are being.
Identity. It responds to your state of being.
And your state of being is encoded in emotion. This is the key link to Dispenza's work on coherence. A thought is the language of the brain. An emotion is the language of the body. If your brain says, I am wealthy, but your body feels the familiar clench of, I'm afraid of being broke, the body always wins. The electromagnetic signal you are broadcasting is fear. The reflection you get back is more lack.
So the great paradox is you have to feel the gratitude and the joy of the event before it happens.
That is the backwards part. In the Newtonian world, you get the gift, then you feel gratitude. Cause, then effect. In the quantum world, to collapse the wave function of the gift timeline, you must observe it as real now. You must feel the gratitude first. That coherent signal tells your nervous system, and theoretically the field, that the event has already occurred.
It's like you're hacking your own system. You're tricking the brain into thinking the future has already happened.
Or, from a more radical perspective, you are aligning with the version of the present moment where that future is already true. You aren't tricking anything. You are simply tuning your radio dial. You don't create the radio station, you just find its frequency.
And the source mentions that this is incredibly hard because our nervous system loves the past.
It prioritizes safety above all else. The unknown is dangerous. The familiar, even if it's painful and limiting, is safe because we survived it. So the body will fight you, will pull you back into the old emotional loops, breaking that addiction to the past, becoming your future self in the present moment. That's the real work. It's what the Stanford source calls self-hacking.
This connects so perfectly to the idea of the unified field. We've talked about the brain, the heart, and time, but let's zoom all the way out. The Stanford source, John Heglin, talks about the unified field as the absolute basis of everything.
He describes the universe as an ocean. And he used the ginger ale analogy, which I think makes it very clear.
I like that one too. It made the abstract really concrete.
Imagine a glass of ginger ale. The liquid itself is the unified field, pure, still unmanifest potential. Then you see bubbles rising from the bottom.
The particles.
The bubbles of the particles, the electrons, the quarks, the strings popping out of the field into existence. They're temporary forms.
So all of matter is just the surface activity of this deep underlying ocean.
Yes. And the bubbles are not separate from the ginger ale. They are made of the ginger ale, just in a different form. We are made of the field. And the hidden library source takes it a step further. They explicitly identify this quantum vacuum, this roiling field of infinite potential, as the scientific description of God, or the Tao. or source.
They matched the attributes, didn't they? They drew a direct line.
They did. What are the traditional attributes of God in most traditions? Omnipresent. Well, the field is everywhere. It is the fabric of space-time itself.
Omnipotent, all-powerful.
The field contains infinite energy and potential. There's a famous calculation that a cubic centimeter of empty space has enough potential energy to boil all the oceans on Earth if you could just unlock it. And omniscient, all-knowing. The field contains all information, all the laws of physics, all potential futures.
So when we talk about connecting to the field in meditation or collapsing the wave function, we are really talking about interacting with this fundamental intelligence that underpins all of reality.
That is the argument. That consciousness isn't some random fluke of biology that happened on one little planet. It is a fundamental property of the field itself. We are waves on that ocean. We look separate, but we are all made of the same water.
And this brings us to Virginia's story, the near-death experience from the INDS source, because she claims to have gone back to the ocean.
NDEs are such powerful data points that we just can't ignore, especially in this specific context. Virginia describes having a massive heart attack. Clinically, she was dead. Her brain function was compromised, no measurable electrical activity, and yet she reports being out of body.
She said she was floating near the ceiling, watching the doctors work on her. She saw her own body in the corner. But it wasn't just a dream or a hallucination, was it? She saw specific, verifiable details.
This is what researchers call veridical perception. She saw a single shoe on a ledge outside the hospital window, a ledge that was physically impossible to see from her bed, or even from most places in the room. She described the specific instruments the doctors were using. Later, when she was revived, a nurse checked the ledge, and the shoe was there, exactly as she described it.
That just chews me to the bone, because if her brain was off, how was she seeing? Where was her consciousness?
This connects right back to the brain as receiver theory. If the brain is just a radio, like we mentioned, then when the radio breaks, when the heart stops and the brain shuts down, the signal doesn't die. The consciousness simply delocalizes. It stops being focused to the physical body and expands back into the field.
She even said she felt like she was being taught quantum physics while she was out there.
But without the math. She said she understood it experientially. She understood that we are all light, that we are all particles of this one field. She said she felt the profound interconnectedness of all things, which is basically a spiritual description of quantum entanglement.
It's amazing how these completely different sources, the hard math of Penrose, the practical biology of Dispenza, the mystical experience of Virginia, all seem to be circling the same bonfire.
They are. They're all using different languages, math, biology, spirituality, but they're all pointing to a reality that is far more interconnected, more fluid, and more responsive to consciousness than we ever dared to believe in the 20th century.
So let's try to bring it all home. We have covered a massive amount of ground today.
We certainly have.
We started with the double-slit experiment and the delayed choice, which showed that observation collapses possibility into reality, and that our linear view of time might just be an illusion. We looked at the hardware, the microtubules that might make our brains quantum devices, shielded from the surrounding noise.
Then we went to the heart's magnetic field and how achieving coherence can literally change our biology at the genetic level. And finally, we look at the idea that we can manifest reality by tuning our identity, our very being, to the frequency of a future that already exists.
And we listen to the skeptics. We have to remember that. We acknowledge that the brain is a warm, noisy place, and that words like energy have strict scientific definitions.
We did, but we also saw the compelling counter-evidence that biology uses quantum tricks all the time, from birds to plants, and that the Orcher-Orris theory provides a viable, testable mechanism for how it could work in us.
It feels like the tension between the skeptic and the mystic is actually really helpful. It keeps the conversation honest.
It is absolutely essential. You need the skeptic to keep you grounded, to stop you from thinking you can fly just because you vibrate high. But you need the mystic and the quantum theorist to remind you that the ground you're standing on isn't nearly as solid as it looks.
So the conclusion seems to be that we have far more agency, more influence over our lives and our bodies than we thought.
That is the core takeaway. Whether you view it through the lens of rigorous quantum mechanics or through practical psychology and the placebo effect, the result is the same. Changing your internal state, your thoughts, your emotions, your focus, changes your external reality. Your biology responds, your perception responds, and maybe, just maybe, the field itself responds.
You are not just a passive observer watching the movie of your life. You're in the projection booth.
Or maybe you are the screen, the projector, and the movie all at once.
Which leads us to our final provocative thought. I want to leave everyone listening with this. We talked about the observer effect. The act of observation is what collapses reality from pure potential into an actual experience. And we talked about the unified field, that deep underlying intelligence that is everywhere.
Right. The ocean and the waves.
So if the observer is what makes reality real, and deep down, we are all expressions of that one unified field. Are you just a tiny person observing the universe, or are you the universe observing itself through your eyes just to see what happens next?
And if you are the universe observing itself, what kind of show do you want to watch?
That is the question. Thanks for taking the deep dive with us. See you next time.